Alright, last time we had talked about immunization. In particular, we talked about Reddington immunization, which was a method of immunization that would protect companies against the adverse effects of small changes in interest rates. Today we want to talk about full immunization, and full immunization is going to be stronger than Reddington immunization. It's not only going to protect against small interest rate changes, but it's going to protect against any change in the interest rate here. So could go down to 0%, could go up to 200%. If you have full immunization, then there's going to be no adverse effects on the company. So the first two conditions for full immunization are the same as Reddington immunization. That is, the present value of the assets has to equal the present value of the liabilities. That is, the cash flows of the assets and all the liability cash flows, the present values of those equal. And then the duration of the asset cash flows has to equal the duration of the liability cash flows, and that could be Macaulay duration or modified duration, either one, as long as you're consistent with both. And then the third requirement is, it's pretty simple. Before we were looking at, with our third requirement for Reddington, we had to have that the convexity of the assets was greater than the convexity of the liabilities, and that was a condition that involved the second derivative of the price. Well, here it's a little simpler condition. We just need two asset cash flows for every liability cash flow, so a 2-to-1 ratio there. And one of those asset cash flows has to be before and one after the cash outflow. So a simpler third condition to work with. Just a note here, full immunization is stronger than Reddington immunization. So if you have full immunization, so if you satisfy this third condition, then you're going to have Reddington immunization. So that means that automatically the convexity of the assets is going to be greater than the convexity of the liability cash flows. Well, let's look at an example here of full immunization. So we've got a firm that needs to pay one liability cash flow in 3 years, and zero coupon bonds with terms of 2 years and 5 years are available. Notice that the liability cash flow occurs in 3 years and that the terms of the bonds are both shorter and longer than the duration of the cash flow, the liability cash flow, that is. And that has to be the case. Those are the only bonds that are available to invest in. Both of them are at 6% EAR. So that would usually not be the case. So we're making a simplifying assumption in this example. We're assuming a flat yield curve. Long-term investments have the same effective rate as short-term investments. How much of each type of bond should be purchased to guarantee full immunization? And then we want to show that the immunization is going to hold even for large changes in interest rates. So we've done a few of these problems before, and they kind of all start out the same way, where we want to know how much of each type of bond to purchase. We're going to let X be the amount of the 2-year bonds, and that's at maturity. So these are par values of the bonds, not the discounted value. Cap Y is going to be the amount of 5-year bonds at maturity, both zero coupon bonds. So the first condition, we need present value of the asset cash flows has to equal the present value of the liability cash flows. Well, there's only one asset cash flow. There's only one liability cash flow, and then there's two asset cash flows. So we've got time 0 here, and 1, 2, 3. We've got this liability cash flow of $5,000 in 3 years at time 3. And then at we've got time 2 and time 5 is when we're going to have our asset cash flows. So we are going to receive X at time 2, and we are going to receive Y at time 5. So the present value of the liability cash flow, well, let's do the assets on the left. Present value of these two asset cash flows were brought back with the same discount factor, so X has to be brought back 2 years. So this is going to mean that x times v squared plus present value of y, bring that back 5 years, y times v to the fifth has to equal the present value of that $5,000 liability cash flow. So 5,000 v cubed. And then notice we've got a common factor of v squared that we can factor out and cancel off both sides. Leave a v cubed here and a v here. So this will be x plus y times v cubed is going to equal 5,000 v. Okay, so there's one equation in two variables. We need our second equation in two variables, which is going to come from the durations. So we need the duration of the assets to equal the duration of the liabilities. Okay, well, duration of the liabilities is really easy. There's only one liability. It occurs at time 3, so the right-hand side here is just 3. And then on the left-hand side, the duration of the assets, let's use Macaulay duration for this example, and recall that that's the present values of the cash flows weighted by the durations, divided by the sum of the present values of the cash flows, which is just the price. So on the top here, we want to do the present value of x, which is going to be xv squared. And then that's going to be weighted by the time, which is 2, plus the present value of y, which is yv to the fifth. And that's going to be weighted by the duration of y, which is 5, happens at time 5. And then down on the bottom, we just do the present values of those two cash flows, which is xv squared plus yv to the fifth. Now, since the present value of the asset cash flows equals the present value of the liability cash flows, we can actually simplify this denominator a little bit, because this is going to be our second equation in x and y, and this is pretty yucked up with both x's and y's on the top and the bottom. So notice that this thing down here, the xv squared plus yv to the fifth, by this equation up here is equal to 5,000 v cubed. Okay, so notice that this equals 5,000 v cubed, and that's by condition 1. And so then our left-hand side becomes, well, let me rewrite this just a little bit here. Let me write all of our coefficients out in front of the x. So 2v squared times x plus, let's take the 5v to the fifth out in front. 5v to the fifth is just a number because v is a constant, times y, and now we're dividing by 5,000 v cubed, and that has to equal 3. And then if we cross multiply, or if we multiply both sides by the denominator, clearing out the fractions, then we get 2v squared x plus 5v to the fifth y will equal 3 times 5,000 v squared, so 15,000, I'm sorry, v cubed, 15,000 v cubed. And then notice we've got a common v squared that we can cancel off both sides. So remove a v squared, that'll leave a v cubed, and then a v here. So this is going to be 2x plus 5v cubed times y equals 15,000 v. And there's our second equation. So our first equation in two unknowns x and y here, our second equation in two unknowns x and y there. So now we want to solve this system, and you can either do it by substitution or elimination. This one works out. It's not too bad to do it by elimination. So let me just rewrite this equation up here. So this is 2x plus 5v cubed y equals 15,000 v. And now let's bring this equation down. X plus v cubed y, put the coefficient out in front, is going to equal 5,000 V. And now we can make the x's cancel out by multiplying through by 2, or we can make the y terms cancel out multiplying through by 5. I'm going to make the x's cancel out, so it's multiplied by 2 here, 2 here, and then multiply by 2 on the right, and this 5,000 will be 10,000. If you'll let me do that in one step. And now subtract those guys. X terms cancel out. 5v cubed y minus 2v cubed y is 3v cubed y. 15,000 v minus 10,000 v is 5,000 v. And now divide both sides by 3v squared. So y is going to equal 5,000 v. Divide by 3v, oh I'm sorry, that's v cubed. Divide by 3v cubed. So this v will cancel here and leave us a v squared on the bottom. So this is 5,000 over 3v squared. And then remember here that v is, our effective rate is 6% here. So v is going to be 1 over 1.06. So now all we have to do is plug in our v. And so if you do that and you do the calculations, you will get 1872 and 67 cents. So there's our y. And then to get our x, let's go back to this original equation. And we'll plug in our y. So then we've got x is going to be equal to, let's bring this over as a negative, 5,000 v minus v cubed times y, which is going to be 5,000 v minus v cubed, and then plug in our y, 1872.67. And then again, v here is 1 over 1.06, and you do the calculator work there, and you get 3144.65. Okay, so we've got our two amounts. So we're going to purchase a par value of 3144. X is the amount of the 2-year bonds. So 3144 of the 2-year bonds and 1872 of the 5-year bonds. Okay, so this is the par of the 2-year. And then this one is going to be the par of the 5-year. So that answers the first question here. How much of each type of bond should be purchased? And now we want to show immunization holds for large changes in the interest rate. So we can see that our third condition here for full immunization holds, but I didn't prove that as a theorem. Okay, I stated it. We didn't prove it. But let's check in a couple of empirical cases to make sure that this is doing the right thing. So what if the interest rate were to fall down to 0% from the 6%? Would they be in better shape? So, well, if I was equal to 0%, then that means your V, which is 1 over 1 plus I, is 1 over 1 plus 0. So V just equals 1. So then the present value of the assets is going to be xv squared plus yv to the 5th, same equation that we had up here. But then both of these guys are equal to 1. So this is equal to 1, and this is equal to 1. So this is just x plus y, which is our 1872 plus 3144, 5017. And then the present value of the liabilities, that's your right-hand side here, 5,000 v cubed, which again, this is 1. So that's 5,000 times 1, which is 5,000. So the present value of our assets here, 5017, is greater than the present value of the liabilities. So we are in better shape if interest rates drop. because at 6% the present values are equal. Okay, at 0% present values of the liabilities are less than the assets. So here we've got present value of the assets is greater than present value of the liabilities at 0%. So we're in better shape there. Okay, well, what if interest rates went up to 100%? So that's saying I equals 1. Well, then 1 plus I is equal to 2, so your discount factor is 1 over 2. And so then present value of the assets is going to be xv squared plus yv to the fifth. V squared, 1/2 squared is 1/4. 1/2 to the fifth here is 1/32. So then if you plug in x and y, 1/4 times 3144 plus 1/32 times 1872, you get $844. And for the liabilities, the 5,000 V cubed, when V is 1/2, is 5,000 times 1/8, which is 6,250. And again, present value of the assets here is equal to present value of the liabilities. So present value of the assets is actually greater, I'm sorry, I said equal, is greater than present value of the liabilities at 100%. Okay, so it was greater if the interest rate dropped, it was greater if the interest rate increased significantly, and they were equal at 6%. So this truly is a minimum. It's a minimum value. So remember, the idea of Redington immunization was if concavity of the assets was greater than the concavity of the liabilities, that meant that you were concave up and you had a relative minimum. Now just a note on rebalancing here. Notice that immunization is a continuous process. It's not a once and done process. I mean, once you immunize, well, you're okay temporarily. You're protected against small changes in the interest rate. But then in the course of business, you're going to be taking on additional liabilities and you'll be adding assets just in the normal course of business. Well, once you add those assets and liabilities, you have to re-immunize. Because remember, we need one asset cash flow before and after each liability for full immunization. And if we want Redington immunization, well, once you add an asset or a liability, the convexity changes. So this is a continuous process. Another thing, even if you just kept the same assets and liabilities, another thing that can happen is just at the passing of time here, that changes the duration even of the existing cash flows. Okay, the time to the cash flow decreases. So even if you had no more assets and liability cash flows, and even if you had constant rates, the duration is going to change. And the duration is going to affect the second condition of immunization. Okay, that the duration of, in both cases, Redington and full, duration of the assets has to equal duration of the liabilities. These things change with time. So that's another reason that it's a continuous process. And then thirdly, I mean, if interest rates do change, convexity and duration change at different rates with respect to interest rate changes. So that means that you might lose immunization. So all of these things are pointing to the fact that immunization is not a one-time only process. Now, one method of immunization that makes a lot of sense and is easy to work with and easy to do exam questions for is what's called exact matching. So I want to talk about the immunization by exact matching method. When you do exact matching, you make sure that the asset cash flow at time t is equal to the liability cash flow at time t for all times. Okay? And think about what happens when you do this. Okay? If your asset cash flows exactly match your liability cash flows at all times, then what is going to be the effect of changing interest rates? If interest rates go up or if interest rates go down? Well, if your asset cash flow matches your liability cash flow, when interest rates go up, your asset increases in value, and your liability may also increase, but the interest rates are going to be they should increase by the same amount for each one. And the same if they decrease. Your asset value is going to decrease, but then this value if interest rates are the same for both of them, are going to decrease in conjunction with each other. So they're still matched. So exact matching will achieve full immunization. Okay, it doesn't matter what happens to interest rates. Your ability to pay your liabilities with your asset cash flows is unchanged. So let's look at some examples here. Let's say that a firm has to pay a liability of $500 in 1 year and then $1,200 in 2 years. And the only available investments for them to generate asset cash flows are 1 year zero coupon bonds and then 2 year zero coupons. So notice this was a 1 year and this was a 2 year, and then we had a $500 liability in 1 year and a $1,200 liability in 2 years. And that's not by accident that the maturity of those bonds is coinciding with the duration of the liability cash flows. That's actually on purpose. So it's a 1 year zero coupon bond and a 2 year 8% annual coupon bond. And they're both going to mature at par. So those are only investments available. And we want to know how much of each type of bond to purchase. And that's in terms of maturity value. Okay, so in terms of par value, not market price right now. And then what will it cost if the current effective annual rate is 5%? That's cost right now. So what we're going to do is we're going to work backwards on this problem. Let's go ahead and lay out the time diagram here. So we've got time 0 and time 1 and time 2. And at time 1, we've got a $500 liability cash flow. So I'm doing liabilities above. And at time 2, a $1,200 liability cash flow. And then we're going to have to purchase, for exact matching, we're going to have to purchase an asset at time 1 to offset, and that's going to be the amount of the 1 year bonds. So let's let X be the amount at maturity of the 1 year bonds. And then we are going to need another cash flow at time 2, and that's going to be generated by the 8% coupon bonds. There could be some other cash flows in here, though, than just the redemption of the 8% coupon bond, because you get a coupon payment at time 2. You also get a coupon payment at time 1. So this value X for the 1 year zero coupon is not going to exactly offset that 500. Okay, so it's actually, I don't want to write an X in here. We do have an asset cash flow at that time. We're going to have an asset cash flow, possibly more than one at time 1, and then another one, possibly more than one at time 2. So, well, let's work backwards here. To pay this $1,200 cash flow, if the asset cash flow equals the liability cash flow at time 2, well, the only investment that we have that contributes any asset cash flows at time 2 is the 2 year annual coupon bond. So for that coupon bond, notice that each $1,000 of par value, each 1,000 of par of the 2 year bond, that is going to contribute $1,000 at maturity, because it matures at par, and then there are 8% annual coupons. So there's going to be a coupon that occurs at time 2. So we're going to get the $1,000 back for each 1,000 that we put in, plus another $80 coupon. So each 1,000 of par of the 2 year generates $1,080 in asset cash flow. And that would be cash in at time 2. So if we look at the ratio, then that means for each dollar that we purchase at par value, we're going to get $1.08 in asset cash inflows at time 2 from the 2-year bond. Okay, so $1 of par here is going to produce $1.08 in cash inflow at time 2. So what we want to do is to decide, how much we need to purchase in par value for the 2-year bond. We need to decide, well, how much in cash in are we going to need to offset this $1,200 liability? So in other words, you're saying how many $8s need to go into $1,200? How many $8s do we need to pay off that $1,200? So if you take your $1,200 and you divide it by 1.08, that's going to give you, that ratio is going to give you the amount of par value of that bond that you need. So $1,200 cash out divided by $1.08 cash in is going to tell you how many dollars of par that you need for that bond. So this ratio gives you $1,111.11. Okay, so that's going to be the par amount of the 2-year bond. Okay, so what about the $500 cash flow? Well, we are going to get a coupon from this 2-year bond, as well as the par value and the redemption at time 2. So part of this $500 cash flow is going to be offset by the first coupon from the amount of 2-year bond that we purchase. Okay, so the 2-year bond here, notice that that 2-year bond is going to generate a coupon of 0.08. So it's going to generate coupon of 0.08 times the par value. So 0.08, and our par value we purchased was $11.11. And that is going to be $88.89. And that's going to be at both time 1 and time 2. The coupon at time 2, though, that's already taken care of in this $8 here. Okay, because each dollar in of par generates $8. So if you multiply this by your $8, you completely offset your $1,200. So that's including redemption and the last coupon. But we're going to have a coupon payment of $88.89 at time 1. So that'll partially offset the $500 cash outflow. So this is going to be cash in. So then the remaining cash that we need is, we're going to need an additional $500, because we have $500 cash out then, minus the $88.89 coupon payment, which leaves you $411.11. And that's going to be the par value of the zero coupon bond. Okay, because the zero coupon bond, that's just an accumulation bond. So the maturity value, the par value, is what we're interested in there. So this is going to be the par amount of the 1-year zero coupon. So we've got our two amounts here then. So we've got $1,111.11 of the 2-year, and then $411.11 of the 1-year. The $11.11 plus the second coupon exactly offsets the $1,200. the $411.11 plus the first coupon from the coupon bond exactly offsets the 500. So we're matched. Second question was, what will this cost if the effective rate is 5%? So then the price is just the present value of these cash flows here. And let's go ahead and do the coupon bond first. So that's going to be the coupon payment, F times R, which is going to be for us 88.89. And then you multiply by A angle N. In this case, it's A angle 2 because there's only 2 coupon payments. And then plus bring the redemption value back. So here we actually get to fill in here now some values. So this is going to be an 88.89 coupon plus 11, 11, and 11 cents redemption for the two year. And then this is going to be the 88.89 coupon from the 2-year bond plus the 411 and 11 cents. Don't have a room to write that. So the present value of the 2 coupon payments is here, and then bring back your redemption on the second bond, so plus 11.11 and 11 cents V squared. So that's the present value of the 2-year coupon bond, and then the present value of the $411 zero coupon is just going to be your 411.11, and then bring that back 1 year with V. And V is 1 over 1.05. So if you do the calculator work here, you get 1564 and 63 cents. Okay, and again, that's at time 0. So this is how much we've got to spend altogether at time 0 to get full immunization by exact matching. So you can do this same kind of pattern with more cash flows and get immunization by exact matching. You just have to organize your work. So let's take a look at another example here. Here in 921, we've got a company that expects some cash outflows of $100, $300, $500, and $400 at times 1, 2, 3, and 4 respectively. And we have available investments are just annual coupon bonds. 1-year coupon has a rate of 4%, 2 years 5%. So this is the effective rate. No, I'm sorry, these are coupon bonds. This is the coupon rate. This is R. So 1-year coupon bonds with 4% coupons, 2-year coupon bonds with 5%, 3-year coupon bonds with 6%, and then 4-year coupon bonds that have 3% coupon. So this is not the yield, but the coupon of the bond. And I set things up in a table here. We're just going to kind of work backwards. We can sketch our time diagram if we want here to look at our cash outflows. So we got 0, 1, 2, 3, and 4. Our cash outflows are going to be 100 at time 1, 300 at time 2, 500 at time 3, and 400 at time 4. And we're going to first try and match this $400 cash outflow with asset inflows. So we've arranged things here in a table. I've listed the assets down the left-hand side, and I've listed in reverse order because what we're going to do is we're going to work backwards. First, we're going to offset this liability, the 400, then we'll offset the 500, then the 300, and then the 100, which is what we did up above. Across the top here, I've got time. Okay, so that's time 1, time 2, time 3, and time 4, and then down at the bottom, I've got the total liability cash flows. Let's go ahead and center these guys underneath time here. So in the table, I'm going to put the asset cash flows, and down here I've got my liability cash flows. Okay, so the asset cash flows at time 4 should total up to 400. At time 3, they have to total to 5. Everything at time 2 totals to 300, and everything at time 1 totals to 100. Okay, so let's start with our $400 liability cash outflow. We are going to be matching that with the 4-year bonds that generate 3% coupons. Okay, so again, each we look at what 1,000 par would. Each 1,000 par of the 4-year bond for your coupon bond is going to give us cash inflow of the $1,000 redemption plus the coupon at time 4, and then it's going to give cash inflows of the coupon payments at times 3, 2, and 1. Okay, so but it's going to give 1,000 plus these are 3% coupons, so $30 on $1,000 par. So this will give $1,030 of cash in. At time 4. So again, just if you look at the ratio, then we want to figure, for each dollar of par, we want to figure out, how many dollars do we have to purchase at par. Each dollar of par generates $1.03 of cash in. Okay, so let's see here. So $1 of par equals $1.04. I'm sorry, $1.03. Divide both these guys by 1,000. $1.03 of cash in at time 4. That's redemption and the last coupon. So how many of these $1.03 cash-ins do we need? Well, enough to cover that $400 payment. Okay, so then if we take 400 and divide it by 1.03, $3.88 and 35 cents. And that's going to be the par of the 4-year. And actually, just to make things handier here, let's write our interest rates down here as we're using them, our coupon rates. So off to the side, R for our 4-year is 0.03, and for our 3-year it's 0.06, and for our 2-year it's 0.05, and then for our 1-year 0.04. Alright, so that's the par amount. So that gets generated at time 4 as a cash inflow. So we're going to have 388.35 here. Now that's a coupon bond, so it's also going to generate coupons at times 1, 2, 3, and 4. Okay, so here we've got our cash flow of 388.35. That's how much of the 4-year that we buy. That's going to generate coupons at times 1, 2, 3, and 4, and the coupon amount is going to be 3% of the 388.35. So 0.03 times our 388.35, and that will give us 11.65. So we're also going to have at time 4 an 11.65 coupon that's going to be cash in, and these two exactly add up to $400 because none of these other investments are going to contribute at time 4. And then we've got 1165 here at time 3, coupon from the 4-year at time 2, and then also at time 1. Alright, so that's the 4-year bond. So next we look at the 3-year bond. We're going to have a cash liability outflow of $500. 1165 is going to be taken care of by the coupon from the 4-year bond. So we want to subtract that off first. So 500 minus 1165, cash out minus cash in, is going to give us 488.35, and that will be the remaining cash out. So we have to offset that, and we're going to offset that with 3-year bonds that are at a 6% coupon. Each dollar par of the 3-year bond is going to generate 1.06 in cash inflows at time 3. So in order to find out how much we need of the 3-year, we're going to take that 488.35 and we are going to divide it by 1.06. It's 1.06 cash in per $1 par value. And this will give us 460.71. And that's going to be the par of the par that were needed of the 3-year. So that's going to be a cash inflow at time 3. We're going to have a 460.71. And we are also going to have a coupon at time 3, 2, and 1 from that bond. So our coupon is going to be equal to 6%, 0.06, times that 460.71, which is 27.64. So we'll have a 27.64 here at time 3 that gets added to our redemption of the 3-year bond, and then also 27.64 at time 2 and time 1. Now these are the only cash flows that are going to occur at time 3. If you add these up, they add up to $500 exactly. So the 3-year and the 4-year together offset these two cash flows. And then we need to next offset this $300 cash flow. We already have cash inflows of $1165 and $2764, so subtract that off and that'll tell us how much is remaining. So we're going to take our 300 here, and we are going to subtract off the sum of the coupons we already have, cash inflows we have, 1165 plus the 2764, and that leaves us 260.71, and that's remaining cash out. And we're going to offset that with cash inflows with the 2-year bond. So we're going to take our 260.71 and we're going to divide it by, for the 2-year bond that has 5% coupons, so each dollar of par value that we purchase is going to generate $1.05 at time 2. So we're going to divide this by 1.05, and that will give us 248.30. And that's the par of the 2-year. That's how much we want to purchase of the 2-year. And so we're going to have a 248, whoops, not there. Going to have a 248.30 cash inflow from redemption at time 2. And then we're going to have 2 coupons. And so our coupon here is going to be 5%. So 0.05 times the par value that we purchased, which is the 248.30. And that is going to be $12.41. So we'll have a $12.41 coupon here to add in, and then we'll have a $12.41 coupon here. And let's give us some more room here. Okay, so these amounts at time 2 exactly add up to the cash outflow of $300. So we're set there. We just need to work with the 1-year bond. So we have a $100 cash flow at time 1. It's already offset partially by 1165, 2764, and 1241. So our remaining cash outflow is going to be 100 minus the sum of those, 1165 plus 2764 plus the 1241, which leaves us 4830, and that's remaining cash out. And again, that's at time 1. And we're going to offset that 4830 cash out with 1-year coupon bonds. Each dollar of par is going to give you $1.04 of redemption. That's redemption plus the last coupon. So we take that 4830 and divide it by 1.04. Redemptions per par dollar spent, and that is going to give you 46.44. And that's the par of the 1-year bond. So we're going to have a 46.44 at time 1, but then we're also going to have a coupon, 4% coupon. So then our coupon also at time 1 is going to be 0.04 times that 46.44. Small coupon, $1.86. And that goes in here at time 1. And you can double check that this does add up to $100. So your assets exactly offset your liabilities at time 1, time 2, time 3, and time 4. Doesn't matter what happens to current interest rates. Okay, these coupons are going to stay the same, assuming the bonds don't get called back, and we are assuming that. So it doesn't matter what happens to interest rates as long as we've got non-callable bonds. And I think if they were going to allow callable bonds in the problem, they would actually physically say that. So what is the question asking for here? We go back and just double check. It expects to have liabilities at these times. The available investments are below. I forgot to state what the question is asking. They want to ask how much of par value of each type of bond should we purchase to get full immunization by matching. Okay, so that's what we wanted here. So how much par of each bond should we purchase? For exact matching. So we want to go ahead and answer that question, and that's going to be these amounts right here. No, I'm sorry. These are the redemption amounts. We don't want those amounts. We want these amounts here: 388, the 460, the 248, and the 4830. So we're going to do 4830 of the 1 year, 240. Yeah, that's right. Just thought that was a little unusual. 24830. I was seeing 4830 and 24830. That was just by chance of the 2 year. 460.71 of the 3 year, and then 388.35 of the 4 year. And then if we were given an effective rate, then we could actually price this portfolio at current prices. And in fact, we will do that in the next example here. So, oh, okay, so yeah, duh. So, yeah, oh, yeah, these are not correct. That was a previous revision of the problem. Okay, and then yeah, we need yield rates to price. So we've got our portfolio, and if we had a yield rate, then we could just price those just using the cash flow valuation formula for bonds. FR times A angle N plus C times V to the N. Okay, last example, another exact matching example here, and we're going to price. And this one's set up as a multiple choice. So we've got a firm that has liabilities of $50,000, $30,000, and $100,000 that have to be met at the end of 1, 2, and 3 years respectively. Firm wants to exactly match, so we're doing exact matching for our immunization. So we want to exactly match the liabilities using only the following assets. Got a 1 year 0 coupon bond with a yield of, that's a yield of 5%, a 2 year 0 coupon with a yield of 6%, and a 3 year coupon bond. Oh yeah, coupon bond. There we go. Coupon bond with coupons of 6%. So this is our R, okay, and this is our I, yield for that. So, and these two values are I. So the value for I is just going to let us price the portfolio at the end. R is our coupon. So what's the total cost of the portfolio that exactly matches the liabilities? So notice that each one of these guys has a different yield rate, 5%, 6%, and 6.5%. The yield rates increase along with the term of the bond. And that's looking at the yield curve and interest rate sensitivity to time. And so we'll take each one of those bonds. When we do price it, we'll price it with its own interest rate. So, and we're going to start out working backwards again. So I've got a similar table to what I had before. I list the assets down the side, 3 year, 2 year, and 1 year bonds. The 3 year is the only one that's got a coupon here. So I'm going to list that R out to the left-hand side, which is a 0.06. And then I've got our liability totals down on the bottom there. And why don't we move those over and center them underneath 1, 2, and 3. So we need the total in each column of asset cash inflows to equal these liability cash outflows. So we start off the same way that we did before when we had the coupon bond. So we've got $1,000 of cash outflow that we need to match. And for this coupon bond, each $1 par generates 1.06. Okay, so for the 3 year bond, $1 par equals 1.06 cash in at time 3. So we're going to need to match that $100,000. The only place that's going to come from is the 3 year bonds. because they have duration the same as the cash flow, same as the duration of the cash flow. So we're going to need 100,000 divide by your 1.06. Which is 94,339 and 62 cents. So that's going to be the redemption value that we need. That's going to be, yeah, actually we want to break this up with the coupons here. So this is going to be the redemption value that's generated at time 3. And then we'll have to add to that the coupon. So yeah, so we want our 94,339 62. Since we're redeeming at par, that par value is going to be the redemption value, and we got to figure our coupons here. So our coupon for this guy is going to equal 0.06 times our 94,339, 0.62, and that's going to generate some fairly good sized coupons of 56, 60, 38. So I'll have a coupon of 56, 60, 38 at time 3. Going to have one at time 2. And one at time 1. Okay, now the 2-year and 1-year are 0 coupon bonds. Okay, so we don't have to think about coupons there. All we have to do is make sure that we're going to cover the remaining cash outflow. Okay, so at time 2, we got a cash outflow of 30,000, a cash inflow of 5,600 already. So the remaining cash in that's needed is going to be 30,000 minus your 56, 60, 38. Which leaves 24,339, 62. Okay, that's the redemption value or the par value that's going to be needed for that 0 coupon bond. Okay, so this is going to equal, this is remaining cash out. But it also means that that is going to be the par of the 2-year. That we need to purchase. So 24,339 is going to be exactly offset by the 2-year. So 24,339, 62 by the redemption of the 2-year bond. And we'll find the cost of that in just a minute, and that's where our yield rates are going to come in. And now this doesn't generate any coupons, so we're set here in column 2. These guys add up to 30,000, and now we need to cover 50,000 liability at time 1. 5,600 is already offset by that first coupon cash inflow. So time 1 remaining cash out is going to be your 50,000 minus 56, 60, 38. And that leaves us with 44,339, 62. And this is remaining cash out at t equals 2. And this is remaining cash out at t equals 1. And so that's going to equal the par of the 1 year that we need to purchase. So we are going to need to purchase 44, 339, 62. So this one was a little bit less involved, but look what they're asking us here. What is the total cost of the portfolio? Okay, so we know the par values, but that's not what it's asking for. Now we've got to price these. Okay, so first we'll do the coupon bond here. So our price is going to be our present value. So we're just going to take each one of these as cash flows and bring them back. So the 3-year coupon bond, we've got 3 coupons of 56, 60, 38. So we're going to have the 56, 60, 38. That's our F times R. And multiplied by A angle N. Okay, so that's going to get multiplied by A angle 3. And that's going to be at the interest rate that goes with, when we discount those payments and bring them back for the 3-year bond, that's going to be at the rate for the 3-year bond, the effective rate, which is, for the 3-year bond, the yield is 6.5. So this is going to be at 0.065. Plus then the redemption value of the 3-year bond is the 94,339. So 94,339, 62, and that's going to get brought back 3 periods. So that's going to get discounted with, we'll call that discount factor V3, and it gets cubed. So V3 is the discount factor for the 3-year bond. Okay, so I is 0.065, so here V3 is going to be 1 over 1.065. That'll be the discount factor for the 3-year bond. For the 2-year, the effective rate is 6%, so V2 is going to be 1 over 1.06. And then for the 1-year bond, V1, discount factor that's got to be used to price that is 1 over 1.05. Okay, so that's the current price of the 3-year bond. And then we've got to price the par or the redemption value of the 2-year bond. So that's going to be the 24,339.62. And to figure the present value of that, we take the second discount factor and we square it. So that's going to be V2 squared, 1 over 1.06 squared. And then lastly, we take the par amount here of the 1-year bond, the 44,339.62, and we bring that back with V1, the first discount factor, 1 over 1.05. So if you do the calculator work here, you get 156,980 and 73 cents. So if we look back at our choices here, 156,980, that's going to be closest to 157,000. It's $20 off here. 156,700, that's $280 off. So this is pretty close. So that's an acceptable amount of rounding, $20 for a $150,000 portfolio. So, but notice again here that we're using the rate, the effective rate, the yield that corresponds to each bond in order to price it. All right, so you should be all set here on full immunization and exact matching, which finishes up the problems in the rest of Section 9, the practice problems.